special edition of our English language session. Today we're going to see a very simple thing in mathematics. Assalamu alaikum wa rahmatullahi wa barakatuhu, my students in the studio and you out there at home watching me. This is NTA Gusau Learning by Television, a program that is jointly organized by Muslim Student Society of Nigeria ZAMFARA Area Unit in conjunction with NTA Gusau as part of programs and activities as their contribution to our students out there at home that have not been going to school because of this very pandemic of coronavirus, aka COVID-19. My name is Anas Habisullah, student in the studio, and you out there at home, I will be taking you through mathematics. Wow, mathematics. So people will see, mathematics is difficult. No, I tell you, it is only in mathematics that you can get 100 out of what? 100. If it is theory, you will make a lot of noise, English, grammatical problems, you will get something little out of 100. But in mathematics, you can get 100 all over 100. Is that not true? Is that not true? It is. This is mathematics class, and you're welcome. Today, we are going to see a very simple thing in mathematics, but very popular. It is popular, it is simple, and it is all round. And that is indices. Can you say it again? Indices. Indices. This is indices class. Most of the times, you come across problems involving powers. Problem involving what? Powers. Whenever you have issue, whenever you have something involving power, a number raised to a given power, an alphabet raised to a given power, you are dealing with what? Indices. And it is the knowledge of indices that will help you solve that very problem without any problem. And let me tell you, let's go through this and see what is this very power we are calling. Because sometimes these two words, indices and powers, or let me say, or powers. The word indices and powers in mathematics are used interchangeably. When we say indices, it's the same thing as we are saying what? Powers. The singular word of the word with the word indices is what? Index. When you hear the word index, is what? Is the singular of the word indices. And powers, the singular word of the word powers is what? Power. Are we together?
Yes.
Good. Let's look at this. By way of definition, 2 raised to a power of 2. There are 2 numbers here. 1 here and 1 what? On top of it like this. And this is what we call the power. This is what we call what? The power. This is the power. And this is what? This is what we call the base. When you put them together, this raised to power, this is what we call an index number. This number is what? Index number. That is a number that you have written in form of what? A number raised to a given number. Are we together? So this is in a way saying what? This number 2, the base, in how many places? in two places. That is, this number 2 is multiplying itself how many times? 2 times. So this is another way of writing what? 4. So if I ask you to write 4 in index form, this is how you're going to write the number 4. Are we together?
Yes.
I hope you are following me. You out there at home. So another way of writing, let's look at this number 9. I can rewrite this number 9 in index form by writing it as what? 3 raised to power what? 2. 3 raised to power 2, meaning 3 times 3. Here, 2 raised to power 2, meaning 2 times 2. That is that particular number, which is the base, multiplying itself how many times? This time. Are we together? And this is applicable for each and every given number. You can write a number in its what? Index form. Are we together?
Yes.
One mistake I know you people do is that because of this number, that when you multiply 2 in 2 places, 2 times 2 to give you 4, you always assume it is just multiplying the number by the power. No. Like if we have a situation like this, 3 raised to power 2. Somebody may be thinking that 3 raised to power 2 is what? 3 times the number 2. And this is not the same thing as 3 times 3. 3 times 3 is what?
9.
Can you say it again?
9.
3 times 3 is 9. What is 3 times 2? 6. Is 9 equal to 6? No. So by raising a number to a power, you are multiplying that very number, which is popularly known as the base, times itself. That is, this number, it is multiplying itself, the number of the power you are given. So class, and you out there at home, tell me what is 3 raised to power 4? In expanded form, 3 raised to power 4 is what? Say it, let me hear. Is what?
3
3
times
3
times
3
times
3. In how many places? 1, 2, 3, 4. Are we together?
Yes.
And that is how to write a number in what? In index form. This is the index form of which number? Can we do it together? 3 times 3? 9. 9 times 3? 27. What is 27 times 3? 27 times 3. 81. 81. So, the index form of the number 81 is what? 3 raised to power 4. So if I ask you, write 81 in its index form. What is 81 in its index form? 3 raised to power 4. Are we together?
Yes.
Are we together? So if you are just joining us right there at home, pick your pen, a paper, sit down and watch NTA Gusau mathematics class of the what? NTA Gusau Learning by Television program. Now, having done this, there is very important aspect before we go into the real work of indices, which is reciprocal. When we say reciprocal in indices, what do we mean? Can you write it? Reciprocal. Reciprocal. What is a reciprocal of a number? If you have a number this, number A, what is the reciprocal of a number A? Or reciprocal of a number B? If you have a number A or a number B, number A and number B have their reciprocal. What is that reciprocal? If you multiply a number by another number and the result you obtain becomes 1, that very number, you multiply that number A with, is what you call the reciprocal of that number A. So in essence, what we are saying, a reciprocal of a number is that number whenever you multiply two numbers and the resultant, the result you obtain by multiplying those two numbers is 1. Then number A is the reciprocal of number B, and number B is the reciprocal of number A. You are looking at me. You look dull. Maybe example will solve this problem. Assuming I have a number 4, and I want to know the reciprocal of this number 4. So the reciprocal of this number 4 is that number that I can think of. That if I multiply that very number with 4, I will get 1 as the result. So that number I thought of, that number I supplied is the reciprocal of what? Number 4. And 4 is the reciprocal of that number I was able to produce. Can you think of that very number? 4. If I multiply 4 by 4, I will get 16. Is 16 equal to 1? No.
0.
0. If I multiply 4 by 0, the result is going to be what? 0. Is 0 equal to 1? No. 1 multiplied by 4 is 4, and 4 is not equal to 1. Eh? No.
-3.
I know you out there will think of a number that looks like a fraction. Yes. Think of a number that looks like a fraction. 0.5, no. What if I multiply this number by 1 all over 4? Tell me. What is this? 4 multiplied by 1 all over 4 is what?
It's 1.
It's not 0. It is not 16. It is not 0.5. So the result is what? When you multiply 4 by 1 all over 4, the result is what? 1. Therefore, 1 all over 4 is the reciprocal of what? 4. And if I give you this number 1 all over 4, and I ask you to give me the reciprocal of 1 all over 4, what will be the reciprocal of 1 over 4?
4.
It's going to be 4. Are we together?
Yes.
Now tell me, you there, what is the reciprocal of 3?
1 over 3.
Can you say it?
1 over 3.
1 all over 3. Now tell me the reciprocal of 1 all over 2.
2.
The reciprocal of 1 all over 2 is 2, because when we multiply 2 by 1 all over 2, the result we are going to obtain is what? Is 1. Are we all together?
Yes.
Good. Having known this, we can now go into the real aspect, the real working of the indices. To simplify everything, indices has some laws. And those laws of indices help you to solve complex problems involving powers. When you have problems, an equation, an expression that involves powers, looking cumbersome, looking complex, these laws, from complex, you continue to simplify up to the end of the work. You're going to get your result as easy as possible. And that is why you people like physics, because physics has formulas. When you put in your formula, follow the formula, at the end of the day, you get your result without any trouble. So it is in indices. Indices has some laws. And those laws guide you on how to solve problems involving powers. They simplify everything. Now the next thing we are going to see is laws of indices. Can you say after me? Laws of indices.
Laws of indices.
I can't hear you.
Laws of indices.
Laws of indices. indices. There are 6 laws of indices with an extension of 1. Some people see them as 6 because the 5th law of indices is an extension, or the 6th law of indices is an extension of the 5th law of indices. Law number 1 of indices is the multiplication law. Law number 1 of indices is what? The multiplication law. This law tells you that if you have a situation, if you have a problem that involves multiplication of powers, multiplication of what? Powers. Use this law to solve that very problem. And the law is this. It says, a raised to power m multiplied by a raised to power n is the same thing as saying a raised to power m plus n. A as a base, m as a what?
Power.
A as a base, n as a power. When you have this, what is the condition? So long as the bases are what? The same, then what you need to do is just take one base and add the powers. This is the multiplicative law of indices. So meaning to say, if I have a case like this, 3 raised to power 2 multiplied by 3 raised to power 5. By this law, this is the case of indices because we have powers, right?
Yes.
By this law, this is the same thing as what? 3 raised to power what? 2 plus 5, which is the same thing as what?
3 raised to the power of 7.
3 raised to power of 7. If you want it to be in an extended manner, this 3 raised to power 2 means what? It is what? 3 times 3. Is that? Multiplied by another one. This one is how many 3s? 5. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. How many 3s? 1, 2, 3, 4, 5, 6, 7. This is what? 3 in how many places? 7 places. Is it not the same thing as this one? It's the same thing. So, this law simplifies everything. Once you have the powers, once you have the bases the same, all you need to do is what? Look at the powers and add them. Take one base, add the power. Are we together?
Yes.
This is multiplication law of indices. We're going to see other examples, other complex examples. But let's see the division law first. The division law is it goes this way. When you have a raised to power m divided by a raised to power n, this result is the same thing as what? A raised to power m minus n. What happens? Division becomes subtraction. When you have division and the bases are what? The bases mark you. The condition for these laws to apply is what? That the bases must be what? The same. All you need to do is what? Subtract the powers. A raised to power m divided by a raised to power n is the same thing as what? A raised to power m minus n. Are we together?
Yes.
Are we together? Yes, we are. So this is to say, if you have 2 raised to power 3 divided by 2 raised to power 2, the result of this is what? 2 raised to power 3 minus 2. And this is what? 3 minus 2 is what?
1.
Eh?
1.
1. This is 2 power 1, which is the same thing as what?
2.
2. Are we together?
Yes.
This is the multiplication. This is the division law of indices. I believe you are not fed up, and I believe you are ready to take the next law of indices, because I told you there are 6 laws of indices. But for the purpose of this class, this is where we're going to stop. By now, I believe you know how to write a number in its index form. And I know you know how to solve problems of indices that involves multiplication and those that involve division. Is that true?
Yes.
Is that true?
Yes.
Yes, it is true. And to confirm this, I want you to do this. Take your pen, write this. 3 raised to power 5 multiplied by 3 raised to power 6. Don't give me the answer now. Keep the answer. Next class, you will tell me this answer. Number 2. 2x, right, 2x raised to power 3 multiplied by 3x raised to power 5. I hope you have taken it.
Yes.
And number 3, the last one, a raised to power 7, a power 7 divided by a power 3. Next class, you're going to supply answers to this, and let me tell you, I won't accept a 0 result. This is mathematics, and you can get 3 all over 3.
Right.
Until then, I wish you a happy stay. Bye-bye.